Welcome to Found in Space, a science podcast for kids and teens.
When you think about space, what's the first thing that pops into your mind? Someone says, hey, outer space. Well, I don't know for you, but for me, the first thing I think of would be stars, rockets, planets, maybe a planet like Saturn with a ring around it. So let's explore the idea of stars, because that's pretty important when we're thinking about space. Now, a star, you've probably seen one in your life before. Now, the darker the area is that you live, so let's say you live out in the country, or maybe you live on a boat in the middle of the ocean, you're going to be able to see a lot more stars at night than the folks who live in a city. So the more light and the more light pollution there is, the harder and harder it becomes to see the stars. But in the past, our ancestors, no matter where they lived, they would have been able to see the stars, even if they were in the middle of a city like London, say, because we didn't have artificial lights yet. And although we did have light, it was mostly fire, and that wasn't very bright. Really wasn't until the last century, so centuries 100 years or so, that we've had widespread use of electric lights. So you can still see some stars, usually in a really bright city. But if you're out in the country, when you look at the night sky, on a night that it's moonless and there aren't any clouds out, you can probably see thousands of them. Literally thousands of points of light. Now, at first, those points of light are all going to kind of look like white specks to you. But if you give it a little bit of time, those specks, those white specks, you start to see that there's differences in how bright and dim they are. And there's differences in the colors. Some of them are a red and others a very pale blue. You get these whites and kind of oranges in between. So we've been wondering about these objects for millennia, for as long as we've been able to see them, as long as we've been able to look up and wonder. Now, it wasn't until fairly recently, within the last few centuries, that we realized something really amazing. And that is that the sun is a star. All those other stars out there, most of those are suns too. Most of them have their own planets. So we're going to come back to that in a later episode. But for now, the realization that the stars, that the stars are like the sun and the sun is like the stars, is really amazing, because that means we can study the sun and learn about other stars. Now, stars are like people, that they're all completely different in some ways, right? They're all very different, but there are some things that are similar about humans. Most humans, not all, but most of us have the same body parts, right? Most of us have 2 arms and 2 legs, and we have a head and 2 eyes and a nose and mouth with teeth in that, etc., right? But then there's differences between us. We are different heights. Some of us are wider, some of us are skinnier, some of us might not have 10 fingers, right? Or some of us have different colored hair or skin or eyes. So stars, they're like that as well. There's similarities between all of them. And you can learn a lot about a human from looking at just one. Pretend that you were some alien coming from another planet and you wanted to learn about humans. And you only had one human that said, okay, you can study me, right? Well, you'd still learn a lot about our anatomy. Same thing with our stars. So when we look at the sun, it's easier to study because it's pretty close to us. It's about 150 million kilometers. That's about 93 million miles away from us. That's much closer than these other objects, than these other stars, which are many light years away from us. Now, a light year, when we talk about a light year, what we're talking about is the distance light can travel in 1 year, because light actually has a finite speed, meaning that it has a top speed that it can travel. Now, that's so fast that from our perspective, it might as well be instant, right? But it actually can't go faster than what we call the speed of causality. So 1 light year is roughly about 10 trillion kilometers, or about 6 trillion miles. So stars are really, really far away. And the closest star to the sun is about 4 light years away. So think about that, 40 trillion kilometers. Yeah. So comparison, the sun is close and big, and we can really learn a lot about other stars from that. So stars are huge balls, right? They're huge spheres. And what they're mostly made from is hydrogen. So this brings us to the topic of elements. And you might have seen the periodic table of elements before. It's often in the back of books. I actually have a coffee mug that has it on it. I've seen people who have it on shower curtains. You'll see it's a list of the 118 known elements. And you could think of these elements sort of like Legos. You could think about them like the building blocks for everything else. So if you put Legos together in different ways, you can make lots of different things. You put it together in one way, you've got this whole bag of Legos, and maybe you make a spaceship, and then you take it apart and you put it together in another way, and you've got a house or a city, things like that. So if you imagine each type of Lego, let's say the small yellow blocks, that's one element. And then you have the small red blocks. You have the long, flat blue blocks, right? So elements are like that. Now, hydrogen is the lightest of all of the elements, and it's the most common, the most abundant of those elements. So stars are made mostly from hydrogen. Now, what makes something a star and not a planet is that it goes through a process called fusion. Now, fusion is actually short for thermonuclear fusion. So thermo is heat. Nuclear is referring to the nucleus, so the center of an atom. Now, an atom is the smallest unit. It's like that Lego of the element. And for a star, they are so massive, meaning they're made from so much stuff that gravity is crushing the center. Now, gravity is that force that we're all familiar with. If you were to pick up something right now and drop it, what's going to happen? It's going to fall towards Earth, right? If you were to stand up and jump, you're going to fall back down to Earth. So that's gravity. Now, with a star, the gravity is pulling in every direction, and it's pulling the weight of all the stuff that the star is made of, which is mostly hydrogen, and it's pulling it and it's crushing the center. And when things start to get squished together, so something you can do with your hands right now, take your hands and squeeze them together as tight as you can, if you're able to do that, and start to feel what is happening to your palms. Go ahead, keep squeezing, tighter, tighter, tighter. Yeah, your palms are starting to heat up, right? Well, this is what happens inside of stars. But stars are ginormous, absolutely huge objects. So it gets really, really hot at the core. And it gets so hot and there's so much pressure at the core that the atoms are forced to smash into each other. And when they do this, they make the next element. They make helium. So the hydrogen gets smashed together to make helium. But this process isn't perfect. And when this happens, it releases a little bit of extra energy. Now, amazing. That extra energy, well, we see that as light. So that's sunlight, or that's the starlight. So when you're standing outside at night looking up and you're seeing those twinkling objects far, far away, trillions and trillions of kilometers away, the light that you're seeing is just the leftover bits from those atoms from the hydrogen being smashed together. Now, that also does something really important. It holds up the star. It fights back against the gravity, against the weight of the material crushing down. And that's what holds the star up from collapsing in on itself. So, all the stars that we see are going through this process. Remember, we said earlier that when you look at a star, some stars are different colors, right? There are some that are kind of red and some that are kind of blue. Well, the color of the star tells us how hot it is. The more mass, so the more stuff the star is made from, well, the faster it's going to fuse through all of that material. So the hotter it's going to be at its core. And the hotter it is, then the hotter it's going to be at the surface, and the bluer the star is going to look. So if you see a red star, you know it's a very cool star. That could mean either it's a very low mass star, so it's not made of a lot of stuff, or it's a very old star that's getting ready to eventually die. And when massive stars die, they explode in an amazing, just hugely energetic explosion called a supernova. And that spreads the star, so it explodes the star, and the leftover material from that explosion is the material for a new star to form. So it's kind of like on Earth. We're used to life cycles here on Earth, right? Maybe the life cycle of a butterfly or a tree or humans or frogs. Well, stars go through that too. They're not really alive the way we're alive, but they form, they develop, and they die, and then we're destroyed, and new stars come from that. And there's some pretty amazing objects that we'll talk about in the future.
So thank you so much, everyone. I hope you have dark skies. Remember to stay curious, and see you next time.